Hello and welcome to the fourth session. In last session, we have stopped with the applications of IoT. Now let's go in detail about it. I'll just take an overview of IoT where it can be easily applied. Let's see smart parking mechanism. So let's see, not exactly shown in the diagram as it is, but we can make up this particular mechanism so much automated. We can see where parking is available, we can report it, we can visualize that, and based on that the parking system will easily work. The resident can identify and reserve the closest available space. Traffic wardens can identify non-compliant usage, and municipalities can introduce demand-based pricing. So in this way the smart parking system can be implemented, or we can make use of like efficient waste management in smart cities supported by sensing as a service. Like we just can identify all of these areas like city council, recycling plants, manufacturing plant, or health safety authority. All that we can connect them in a cloud, and that can be connected to your garbage truck. And once the garbage is collected, then where it's going, it can track it, whether these garbage bins cans are full or not, where they are present, what's the condition of them. All of this we can track with the help of your IoT mechanism. And in smart cities this can be so much effectively implemented. Okay, and all of them can be connected so much easily with the help of an IoT system here. Sensors even in the whole cow, that's also possible. See, in the world of IoT, even the cows will be connected and monitored. Sensors are implanted in the ears of cattle. Okay, this allows farmer to monitor cows health and track their movement, ensuring the healthier, more plentiful supply of milk and the meat for the people to consume. On average, each cow generates about 200 MB of information per year. Okay, you can see this one. This is taken from Matt Harning, and you can connect that sensors in the cow, and their health monitoring system of the cow is possible with this IoT system. Shopping. See, when we go to shopping, the goods will introduce themselves. Yeah, that's how it's possible. When entering the door, scanners will identify the tags on her clothing. When paying for the goods, the microchip on the credit card will communicate with the checkout reader. And when moving to the goods, the reader will tell the staff to put a new one, like in this way. And automated cutting of the money from your account is possible. That's how IoT can be applied into the retail shops. Okay, one more. Can you find this question's answer? How many steps you walk today? Okay, so we need to keep this in mind continuously so that I can identify how many steps I have walked today. But IoT is having a solution to that. Now we can see this one. This is what we call as a fit band. Almost many mobile companies are manufacturing this one, and then providing the facility to find your health statistics, and that can be recorded in their application, Android applications also. This band we can connect to your mobile, Android mobile, and we can analyze the things just like your sleeping pattern. See this one, sleeping, you're awake, you're sleeping, so your statistics of sleeping is shown by them. Okay, and this is one more statistics that we can see. Or I want to know by myself, where are you going, who are you interacted with, how long you have spoken with the friends, so the affinity of connections, how long it takes to get work, what's the tone of your message, amount of text, tweets and updates, how much exercise you are getting, how much you are getting distracted. Lot many things there, all of their answers is there with that feedback, and that's we can achieve out of it. One more, thought control computing. This is not implemented yet. We can see the source. I just given the source over here. Thought control computing. Flagship product Mindwave is a headset that can log into your computer using just your thoughts. Researchers recently used this ECG headset to develop a toy car that can be driven forward with a thought. Okay, so NeoSky smart sensors can also track your heart rate, and other bodily metrics can be embedded in the next generation of wearable devices. That's how it's possible. So we can make use of the IoT system by to control the things with the help of a thought. It's very innovative idea, innovative or many innovation that is there in the generation of computing connecting with the IoT systems. Smart IoT schools, yes, lot many things that we can see. This is very jumbles. Okay, lot many things are added here. So smart IoT school can be created. I just explain few things. See, video capture of the lecture, yeah. Or sensors trash receptacles, robot cleaning, yeah. AI, virtual and augmented reality, that we can make use of in the systems. Or supply and inventory tracking by sensors with auto reorder, that. Or we can have enhancers and exist for Wi-Fi sensors and classroom doors. Okay. Security and surveillance cameras. Fine. Student devices like e-textbooks, notebooks, tablets, smartphones. Fine. This can be added. Like all this smart IoT school. So in school also, in education system also, IoT system can be easily integrated by this method. Now let's see the challenges. What are the challenges that IoT is facing today? There are many challenges present there. If you go to the IEEE Explores website, lot many research papers you can find on IoT, and most of the research papers on IoT are just focusing on to solve the challenge of IoT there. Okay, so most of this. Let's see what are the challenges present in this IoT. The first challenge is scalability, whether the technology is scalable or not. So how we can scale them, how can I integrate multiple technologies together, how it's possible. Or standardization of technology, almost they are connected to each other. Standardization of technologies, how can it be standardized? Can I create a common device which will be used in all the IoT system applications there? Can I use that? Interoperability, operating the device, operating different networks together, communicate different networks together, communicate with different identification devices, addressable devices together. That's what interoperability. Discovery, discover the communicable device, discover the device by which you use to transfer that data. That is discovery. Software complexity, most important part, whether we use a common software, whether we use different communication mechanisms, or if one IoT system using one software, another IoT system using another software, can it be facilitated to communicate between them? That's also one more challenge. Data volumes and interpretation, huge amount of the data is present, and it may reduce the speed of IoT system in many cases. And interpret that data, how can I interpret, how can I store that? Can I use temporal analysis? How can I use the spatial analysis data? So many challenges. Power supply, how the power supply can be given. Is it possible to supply the DC power continuously, or I will be providing my continuous power, or what kind of mechanism I'll be using to make your device continuously live? In case of power failure, what action to do? All these things will be there. Interaction and short range communication, this is also very important part. Short range communication, when we are building a common system application in your home or in a small industry, then how that interaction and short range communication will be taken place. Which mechanism, which communication mechanism you need to focus on, that also you have to decide. Then wireless communication, like we are having Wi-Fi, we are having Bluetooth, NFC, how to embed them or how to make them communicable with each other. That's also main technology challenge that is faced. And the last is fault tolerant. IoT system must be capable of identifying the fault before actually they are occurring, or if the fault is occurred, then also another secondary system should be present to take over the control of it. Can it be done? Can it be possible? Yeah, it's possible, but different ways and systems are still available to get interacted or get added them into the IoT system. These are the common challenges that you need to make sure you have to find the solutions in it. In industrial IoT also these common challenges are present, and now researchers are working to find the solutions of these challenges also. There is one more term like that you might be knowing: big data. Huge amount of data. I've shown that big data here in the form of elephant because there's a tool called as Apache Hadoop, which is very commonly used to analyze the data, and whose logo is containing this elephant there. So big data is not a magic. It doesn't matter how much data you have, you can't make sense of it. If you can't make sense of it, any kind of technology, so whenever using IoT, their data, their main task is to collect the data, and every IoT device is live continuously. It's infinite phase. It is continuously collecting the data, it's continuously analyzing data, continuously storing the data. So if data is continuous, it's collected second by second. So you must be collecting data in huge amount in a day also, in a week, in a month. So huge amount of data is collected, and if you want to extract from that data, so useful power or useful connection communication mechanism should be available to do that. That's what we require the technologies like Apache Hadoop, Apache Mahout, or Apache Spark, which can be integrated into the industrial IoT, so that this big data analysis is so much possible with this, and we can easily control the speed and accuracy of the system also over there. Some of the criticism and controversy that your IoT is having here, like scholars and social observers and pessimists have doubts about the promises of ubiquitous computing revolution in the areas like privacy. This is most important part, privacy. When you're collecting the living and non-living things and communicating with the data, so it's a threat to your privacy of data. Or security also. Security is again the biggest challenge in the IoT, whether you make your data secure, because the hacking of the data or the threats to different confidentiality, availability, authenticity of the data happens only when the data travels through the network. Most of the time when it travels through the network, and IoT is a network, it's a network of networks. So when the network comes, there is always the problem of security present. So how security is provided, what mechanism that inbuilt we are having, what system that we can embed into the IoT to make your data more secure, that should be considered. And this is what the social observers have identified, that their data is not secure. So if you want to make data secure from IoT hub point of view and from communication point of view, this mechanism should be enforced. Then only more secure IoT system we can create. Autonomy and control. So whether it is autonomous system created, how can I control that? Or social controls. So which are the social control mechanisms available? That also we need to think of. Social control means a group of people are controlling the systems. That's how. Political manipulations. We can get your data into the system, but whether it's manipulated by some political forces, it can be there. So that should not be present over there. System should be completely autonomous, and should have capable of taking the decisions, making the decisions of your own, and then an autonomous system can be created. Design, how the design can be done so much flexible, or whether it is non-flexible, like if you're using some microprocessor, microcontroller within that, whether they are flexible to design, whether these boards are flexible, or whether we are having any mechanism by which we can create a raw design and then it can be converted in the form of a product. Like all these things are required to get considered. Then what's the environmental impact of it? Whether you're using a green source of technologies, whether you're making the system reusable, whether you're harming the environment or not. So that things should be considered. So some devices that we use in the IoT are having this impact of environmental impact inside it. That should be considered, and this scholars and social observers has identified, and they have focused whether your device is having any environmental problems or whether it's affecting the environment or not. Okay, that's what you need to focus on. And then the last one is influences on human moral decision making. Yeah, that's also very important part there. Your IoT system is making different decision and they are showing something differently to you, and your mind, your brain is thinking differently, and your decision is different. So the data or the decisions collected by the IoT systems are different. They may have an influence on your thoughts. They may have an influence on your decision making systems. That's why that IoT mechanism to get implemented in your area, in your industry, in your company or not, that your decision makers has to decide. Okay, that's why these particular parts are specially mentioned in criticism and the controversies which IoT mechanism and system has generated, and still these controversies are on, these criticisms are on, and that may arise in your designs also. Okay, so that's from the fourth session of these IoT systems. Okay, thank you, thanks a lot.